capacitance is the, somebody will ask you what is capacitance, you will tell that it is the property of the capacitor. Okay, it is the property of the capacitor. What is that property? Now the property is to store electrical energy in the form of electrostatic charge. Okay, that is your capacitance. You have read it in your 12th standard, 11th or 12th. Yes or no? So got it? What is capacitance? What is capacitor? All of you got it? How do you define a capacitor? What is exactly inside in a capacitor? What is capacitance? Yes, tell me, what is the definition of capacitance? I have told you. Somebody will ask you what is the capacitance. Now it is the what? Property of capacitor. Okay. To store what? To store what? Electrical energy. Okay. In the form of what I have told you? In the form of electrostatic charge. In the form of electrostatic charge. So now here I want to tell you how this capacitor stores the energy or electrical energy. Okay, in the form of electrostatic charge. This you know what is a capacitance. Now how it does? How does the capacitor charge, or how does the capacitor stores the energy? That we will discuss. So now here we have already discussed about the DC circuit. Now we have almost completed. We have completed more than 90% of the DC circuit, the second module. Okay. Now nowhere we have used the capacitors and inductors, right? So now here question comes, why we have not used capacitors and inductors? Yes, you can answer the question after I will complete this DC transient. You can able to answer the question to yourself, why we are not using capacitor and inductors, or suppose we are using capacitors and inductors, what is exactly happening? That we will be going to read here. Understood all of you? Got it? Got it or not?
Yes, ma'am. Yes, ma'am. Can you repeat the last sentence?
I am telling you, after completing, you have already completed 90% of the module. Okay, you have second module. But you do not, you have nowhere you have used, while analyzing a DC circuit, you have never used a capacitor or inductor. But after reading the DC transient, you will able to answer why we are not using capacitors or inductors while solving a DC circuit, or exactly what exactly is happening when you are using capacitors and inductors and supplying, you are providing DC supply to them. Okay, got it, all of you? Understood? Got it or not? My voice is not audible.
Yes, ma'am. Yes, ma'am.
So now come to the charging of capacitor. How does the capacitor charge? Charging of capacitor. Now take a capacitor. Suppose we will consider a capacitor and a resistor we are using. With the help of a switch. Listen to me all of you carefully. Okay. With the help of a switch, we will provide the supply voltage V. This is R, this one is C. With the help of a switch, I will provide, this is the switch S. Okay. Now, I will tell you, I will take 3 cases here. Whatever I am teaching you, as the derivation is important, very, very important. Wherever you will feel doubt, you ask me. There will be little confusion, and you will be having little doubt also. Okay, so ask at any point of your time. Now I will tell you 3 cases. What are the 3 cases? First, I will discuss at switching instant, at the instant of switching. At the instant of switching. That means just at the instant when I am closing the switch, right? just at the instant I am closing the switch, what will happen? Second case, third case is a long time the switch has been closed. Long time switch has been closed. Okay. I have attempted closing of the switch at this, position number 1 or at number 1. Now a long time the switch has been closed. Okay. What will be the condition of the circuit? Second, in between, here we will tell it as t equal to 0. 0 at time equal to 0, we are closing the switch. A long time the switch has been closed, we will take t as infinite. Okay, long time the switch has been closed. What will be the condition of the circuit? What is the potential difference? What is the current? Okay, etc. etc. We will find it out. Now, in between, what is the time? T from 0, t will be greater than 0 and it will be less than infinite. So this is the position number 2. So we call it as any instant. At any instant means we will not consider the instant of switching. Neither we will consider a long time the switch has been closed. Rather, we will consider in between after the closing of the switch and long time the switch has been closed. What exactly is happening in the circuit? Understood all of you? Is there any doubt? So here we will be discussing between 0 to infinite what will happen to the circuit. Clear? Any doubt with this? Tell me.
No.
Okay. Okay, very good. Listen all of you very carefully, very carefully. You'll now suppose I will ask you, you look at the circuit, you tell me at the instant I have closed the switch. The instant I have closed the switch, what will be the current in the circuit? Initially, suppose that you take this charge in the capacitor Q as the charge in the capacitor, Q as the charge of capacitor, okay, and Vc is the potential difference across the capacitor or voltage across the capacitor. You write down voltage across the capacitor. 16 ରେ ରଖିଛି पूरा 16 ରେ ରଖିଛି ଏରା ବହୁତ ଗରମ ଅଛି. Vc is the voltage across the capacitor. Q is the charge of the capacitor. Okay. Now, I will tell you that initially, listen to my question first. Q is equal to 0. There is no initial charge of the capacitor. What is the potential difference across the capacitor? Tell me. There is no charge in the capacitor. So what is the potential difference across the capacitor? Tell me. This is the potential difference across the capacitor. Let it, I am taking it as Vc. And voltage across the resistor, I am taking it as VR. VR is the voltage across the resistor. Okay. Voltage across the resistor. All of you understand properly. Those who I have asked questions before, roll numbers, please understand carefully. I will be asking questions. Okay. Wherever you are having doubt, you ask me. Number of times you are, no problem. Okay, but you should answer the question. Now listen. So now my question is, charge of the capacitor is 0. What is the voltage or the potential difference across the capacitor? Tell me.
Ma'am, when?
When charge is 0? When charge is 0, what will be the potential difference?
0. 0, ma'am. 0.
Potential difference. There is no charge, so there will be no potential difference. तुम लोग का एक बैटरी when you are taking a battery, so बैटरी का चार्ज खत्म हो जाता है, मतलब there is no potential difference. It will unable to provide current to the circuit or current to the device. Yes or no? Like when your mobile gets discharged, what happens? There is no potential difference. There is no electromotive force. So it will not provide any. So similarly, your charge is 0 implies what? The voltage across the capacitor is 0, right? Am I clear to all of you?
Yes, ma'am.
Okay. So now I will ask you that when the switch, the instant I'm closing the switch, just at the instant, because I'm only considering at t is equal to 0, just at the instant I'm closing the switch, right? So what will be the current in the circuit at that time? Q is equal to 0 because I have no charge in the capacitor. There is no potential difference across the capacitor. So what will be the current in the circuit? Tell me.
I think,
Quick.
ma'am, zero, ma'am, because a capacitor will take some time to charge, ma'am.
I am asking what is the current in the circuit. Let the current in the circuit is, let it is I. I is the current in the circuit. Yes, think and tell me. Think properly, all of you think properly and tell me. What is the current in the circuit? Let it be wrong, no issues at all. Nobody is giving you, nobody is evaluating here. Tell. What is the current in the circuit? Just I have closed the switch. My charge in the capacitor is 0. Voltage is 0. What will be the current in the circuit?
मैम जीरो ही होना चाहिए.
आई होगा
Hmm.
मैम बी बाई आर ए बाई आर
V by?
ए बाई आर
V by R. How do you get V by R? Tell me. Justify. How do you get? Quick, tell me.
क्योंकि कैपेसिटर चार्ज नहीं होगा बस भी से पोटेंशियल आ रहा हूँ
V से पोटेंशियल आएगा तो ओके ओके वेरी गुड so I will discuss first at the instant at switching instant. Listen, at switching instant he is correct. V by R answer is correct, but how it is, let us see. So number one, first we will discuss at the instant of switching. At the instant of switching, that means at t equal to 0. Here derivation will come, remember, all of you write down. So at the instant of switching t equal to 0, what will be the equation of the circuit? Just tell me. I can apply Kirchhoff's voltage law because I have closed the switch. I will apply the Kirchhoff's voltage law. Yes or no? Yes or no? Simply you apply Kirchhoff's voltage law. What is the equation of the circuit? At the instant of closing the switch, what is the equation of the circuit? Tell me.
B minus IR equal to 0.
Yes.
What is the equation of the circuit? Tell me. Can I write down capital V is equal to VR plus VC? Am I wrong? Am I wrong? The instant I am closing the switch.
Only VR होगा
Wait. This is the equation, right?
Yes, ma'am.
Okay. So now what is my VC? VC is equal to 0.
Zero.
So V equal to how much? VR.
VR.
VR equal to how much? Some current into R.
IR. Yes, ma'am.
Okay.
Yes.
Some current into IR. So this current is equal to how much? Capital V divided by capital R. So this current V by R current, this is the maximum current flowing in the circuit. That we take it as I maximum. That means the just at the instant I am closing the switch, the current in the circuit is maximum. That is equal to V by R. Am I clear to all of you? Tell me.
Yes ma'am
Yes,
Very
ma'am.
good. Very good. So now what is the voltage across the capacitor? I have told you VC is equal to 0. What is the charge in the capacitor? Q is equal to 0. All of you got it. What exactly is happening the instant I am closing the switch? Got it or not? Sayak, you understood? Sayak,
Yes, ma'am.
who is responding?
Ma'am, 747.
Sayan.
Shayad, ma'am.
Sayan is absent.
No,
Sayan is
present.
absent.
No, ma'am. Shayan is present, ma'am. No, ma'am. Present, ma'am.
Present, how much time you are taking to answer? To respond?
Ma'am,
हाँ?
ma'am, I am saying now the audio.
लॉग इन करके सो गए हो क्या क्या
Yes,
मैम
yes,
लगता है रिस्पॉन्ड करने के लिए ओके सो नाउ हियर यू हैव got the first point is the instant at the instant of closing of the switch. Now come to the third point, last point. What is the last one? Long time the switch has been closed. Long time we have closed the switch. So now what happened to the condition of the circuit? Tell me. What will happen? Tell. A long
Capacitor
time
charge रहेगा.
I closed the switch has been closed
Yes,
to your mobile phone. So what will happen?
The
It will be
mobile will be
100%
fully
charge.
charged.
Yes or no? Okay.
Yes, ma'am.
So here similarly, here whatever the voltage I have provided to the capacitor, that capacitor will charge up to its maximum voltage. What is my maximum voltage in the circuit? Capital V is the maximum voltage.
Yes, ma'am.
So capacitor voltage will be equal to how much? Tell me.
VR plus PC.
Capacitor voltage will be equal to how much? You tell me simple equation. VC will be equal to how much? Capital V. Okay. So now what is my equation? Kirchhoff's voltage law is valid. Once I have closed the switch, Kirchhoff's voltage law will be valid. Yes or no?
Yes, ma'am.
So what is my equation? What was my equation? Capital V was equal to VC plus VR. This is my simple equation using Kirchhoff's voltage law. Yes or no?
Yes, ma'am.
You have to understand
Yes,
carefully.
ma'am.
Now, if at any point of a time I am getting voltage across the capacitor as supply voltage, that means obviously VR is equal to 0. Yes or no? Tell me. Got it or not?
Yes, ma'am.
Voltage across the resistor will be equal to 0. What is the formula for the voltage across the resistor? That is equal to I into R. Simple. This is equal to 0. R cannot be 0. R is never equal to 0. So what is equal to 0?
Current.
What is equal to 0? I is equal
I.
guess.
to 0. That means what? The current in the circuit is equal to 0. Will you agree with me? All of you agree with me that a long time I have closed the switch. The circuit, there is no current in the circuit. All of you agree with me?
Yes,
All of you agree with me?
Yes, ma'am.
A long time, the clue still I am not getting answer to all of you.
Ma'am, VR equal to 0.
I am not telling V are equal to that. V are equal to 0. You have told VC equal to V, na? You have supply voltage. Hey, I have connected. Yes or no?
Yes.
So according to your Kirchhoff's law, VR is equal to 0. I am not telling anything. VR equal to 0 or not? If VC equal to V, VR equal to 0,
Yes,
right? Don't ask me
Yes.
why VR equal to 0. Your law is telling that VR equal to 0. So I am asking, then current is equal to 0. If VR equal to 0, R is not 0. So current is equal to 0, right? So when current is equal to 0, I am telling you, will all of you agree with me that current is 0? A long time the switch has been closed.
Yes, ma'am.
All of you agree with me? Not mathematical. I am asking you practically. You practically think of a circuit.
Practically can't be possible. Practically no.
Ma'am, practically
can't be possible. Practically it will not.
It's not possible.
Zero हो जाएगा.
Why? Why not possible?
current 0 कैसे होगा?
Yes, ma'am.
हम क्लोज सर्किट है
ठीक
ना
है।
बीच में करंट रहेगा ही मैम.
Zero रहेगा.
Yes, ma'am. Minimum amount of
So no.
value तो रहेगा ही.
A long time when a switch has been closed to a capacitor, when the capacitor will get fully charged, there will be no current in the circuit. Why? Because once the capacitor is fully charged, here you see the circuit again I am drawing you here. This is your resistor and capacitor. This is your switch. A long time the switch has been closed to the circuit. This is your supply voltage. This is your R. This one is your C. Once the capacitor gets charged to the supply voltage V, okay, when VC will be equal to V, then what will happen? It will behave as an open circuit. Plus will be accumulated here, minus will be accumulated here. It will behave as an open circuit. Why? Because there will be no potential difference in the circuit. Once the capacitor is charged to capital V, there is no potential difference in the circuit. Current will always flow in the circuit when there is a potential difference. Once there is no potential difference, there will be no current in the circuit, right? So when Vc will be equal to V, then this capacitor will behave as an open circuit. Understood or not? All
Yes,
of you
ma'am.
got it or not? Then at
Yes,
that
ma'am.
time, the current is not equal to, sorry, current is equal to how much? Current is
Zero.
equal to what? Tell me. Zero.
Zero.
Current is equal to zero. Just wait 1 second. हाँ प्रीतम कुह मु क्लास रे अछि
अच्छा मैडम अभी क्लास होनी माने केते फ्री हो
मु फ्री हेबी 4टा रे मोर 4टा रे क्लास सरियो 4 o'clock
ओके ओके ठीक हो
4टा परे तमे करो हैला मैडम को कहि दे 4टा परे प्रेजेंटेशन दबो okay so now when the supply voltage is equal to Vc sorry when Vc is equal to the supply voltage V at that time no current will flow in the circuit the capacitor behaves as open circuit that means to a DC circuit to a DC supply all of you listen all the things are very concept okay all the concept you should know so when you will provide a supply voltage to a capacitor then after some time you will see that the capacitor is fully charged to the supply voltage and there is no current in the circuit. Okay, this is the third step I have told you. Understood all of you? So in the third state, what is happening? Here, what is happening? Vc is equal to V, VR is equal to 0 because the current is equal to 0. Now all of you agree with me now the current is 0? Got it or not?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so I is equal to 0. And what is the charge in the capacitor? I am concerned about the voltage across the resistor. I am also concerned about the charge in the capacitor. What is the charge in the capacitor? Tell me. What is the charge in the capacitor? It will be how much? It will be maximum charge will be there. Yes or no? Because I am getting the maximum voltage. The capacitor cannot charge to a voltage more than capital V. Similarly, what is your Q? Q is the maximum charge or I can write under the final charge. Am I clear to all of you? Number 1 point,
ma'am.
number 3 point, all of you are clear?
Yes, ma'am.
तुम लोगों का सिर कोई
Yes, ma'am.
गर्ल स्टूडेंट्स एक एक बार आंसर देना मुझे ओके सो नाउ कम टू द सेकेंड पॉइंट I have discussed about the first point, discussed about the third point. Now, in between, you tell me what happens. I have closed the switch and a long time the switch has been closed. So this instant we call it as at any instant. So when I am writing any instant means it is not at the instant I am closing the switch. It is not at the instant a long time the switch has been closed. It is in between 0 to infinite. Am I clear? What is this instant? Got it or not?
Yes, ma'am.
Okay, very good.
Yes, ma'am.
So now we will see what exactly is happening. So what is the current in the now? What is happening just after closing of the switch? What will happen? I have the switch has been closed and your voltage is there. But remember that the capacitor has not yet fully charged. Okay, a current is flowing in the circuit. Current in the circuit is your I is the current in the circuit. At any instant, some current will be flowing. Yes or no? Current in
Yes,
the
ma'am.
circuit. All of you got it? Now, what will be the Q is the charge in the circuit. Q is not 0, not a capital Q. Yes or no?
Yes, ma'am.
Q is not 0, not capital Q. I is not 0 or V by R. I is in between 0 to V by R. Q is between 0 to capital Q. What about the VC? VC will be voltage across the capacitor at any instant. Okay. Now you tell me what will be the, I will ask you what is the voltage across the capacitor. Tell me. Can you find out? What is my equation? Tell me. Kirchhoff's voltage will always be valid. VC plus VR is correct. So this will be equal to how much? VC plus I into R. Because that is current in the circuit. Yes or no?
Yes, ma'am.
Got it? All of you are writing or not?
Yes, ma'am.
Yes,
Okay.
ma'am.
So now V will be equal to how much? What is my current? I is equal to how much? Rate of flow of charge is known as current. Yes,
Yes,
or
ma'am.
no? So now Q is equal to how much? You know that. Sorry. So you know that Q is equal to how much? CV. You know, C into VC. What will be the charge in the capacitor? It will equal to C into VC, right?
Yes,
Got
ma'am.
it? Okay. So now here I will substitute I differentiation of CVC. So this is equal to C. Now what I will do it is current. Okay. I will substitute in the current part. So here what will be my equation? Tell me. Capital V will be equal to VC. Check it where if I am doing wrong. I is equal to how much? C into differentiation of VC with respect to time into how much? R. So this is
R.
equal to VC plus RC dVC by dt. Am I clear to all of you? Understood all of you?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Very good. Arey sabas. Nice responding. Good. So now we have this much. Now what we will do it is, can I write down this as dVC, sorry. Can I write down this as dVC divided by V minus VC is equal to minus dt divided by RC. Check it. Check whether it is correct or not.
Yes, ma'am. Yes, ma'am.
Check it whether it is correct or not.
Yes, ma'am. Correct.
Yes or no? Correct or not? Tell me. मेरे बोर्ड को मत देखो, तुम
Correct.
करो, करके चेक करो whether it is correct or not. It is correct?
Yes, ma'am.
Okay, very good. So now what I will do, I will integrate. Suprashad, तमर ହେଲା?
Yes, ma'am.
Equation ହେଲା?
Yes, ma'am. Yes, ma'am.
Integrating both sides. Integrating both sides. Then integrate, do the integration. जल्दी करो integration. Integrating both side, find out what is the answer. ये तुम लोगों के लिए है. Subham, you understood? So Subham, Sasi, Sasank,
Yes, ma'am.
Siddhant, Soham,
Yes, ma'am.
Satwik,
Yes, ma'am.
Samudranil, Samudranil,
Yes, ma'am.
you understood?
Yes, ma'am.
Okay. So here after integration what I will get? Integrating minus dVC divided by V minus VC is equal to integration of minus dt divided by RC. So this
मैम
will be,
माइनस कैंसिल कर देंगे.
हाँ माइनस क्यों कैंसिल करोगे? So this is ln write down. ln how much? B minus VC.
ln of V minus
This is equal to minus T by RC by K. माइनस कैंसिल नहीं करोगे, माइनस तो मैं दी हूं इसको लाने के लिए. What it all of you?
Yes, ma'am.
Okay. So now,
Yes, ma'am.
yes. Now we will find out what is the integration constant K from the initial value. From the initial value, initial condition, when T is equal to 0, what is the value of VC? VC was equal to 0? Yes or no?
Yes,
What is or
ma'am.
not? Now substitute here. ln V will be equal to how much? K. Yes or no?
Yes, ma'am.
Yes, ma'am.
K is equal to ln V. So now what you will do it is, you will substitute now. So this will be substituting here. Take this as equation 2. Substitute here. You will get it as ln V minus VC is equal to minus T by RC. K is your integration constant, that is equal to ln V. Okay, am I clear to this step?
Yes, ma'am.
Okay, very good. So now this will be equal to, this implies ln V minus Vc divided by V is equal to minus T by Rc, or this implies V minus Vc is equal to V to the power minus T by Rc. All of you got it or not?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, very
Yes,
good.
ma'am.
Very, very good. So now this implies what will be the value of V? So this V will be equal to how much? So this implies VC I want voltage across the capacitor. Capital V 1 minus e to the power minus T by RC. Am I clear to all of you? Okay.
Yes.
Yes, ma'am.
So this is the okay. Now this is the equation of the voltage across the capacitor at any instant. You substitute T at 1 second, you will get some value of Vc. 2 second, you will get some value of Vc. 3 second, you will get the some value of Vc. Got it or not? So at any instant, so if I will substitute, what is the relation between Vc and Q? Q is equal to C into Vc, or Vc is equal to Q divided by C. Also this implies I can write down Q divided by how much? C is equal to capital Q, because capital V will be equal to how much? Capital V will be equal to capital Q divided by C, whole into how much? 1 minus e to the power T minus RC, or this implies your Q will be equal to capital Q whole into 1 minus e to the power minus T by RC. This is the equation for the charge of the capacitor. This one voltage, this one charge. Got it all of you?
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am.
Okay. So now come to this, you make it as a heading, charge on the capacitor. Charge on capacitor. Okay, take this as heading. Now come to the current in the capacitor. All this equation I am deriving for t from 0 to infinite. Now coming to the current in the capacitor. Current in capacitor. What will be the current in the capacitor? Tell me. What is the equation here? I have got already the equation as how much? Look at here. I have got already the equation V minus Vc equal to how much? This one I have already got this equation. How much is the equation? V minus Vc equal to how much? V to the power minus T by Rc. This equation already I have derived. Yes or no?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay. So from this you find out V minus V is equal to, here also I have written, look at here, V minus V minus V is equal to how much? Where I have written? Yes. From here, can I write down this from this one? V minus Vc is equal to IR? Yes or no? Tell me. This one I can write down.
Yes, ma'am.
Got it or not, all of you?
Yes, ma'am.
Yes, ma'am.
So now here I will write down two equations. One is your, where I have written? One is your current in the capacitor. V minus Vc is equal to V to the power minus T by Rc. Another equation, what was the equation? Tell. V minus Vc equal to how much?
IR.
How much?
IR. IR.
From the this implies I is equal to V by R e to the power minus T by Rc. Or this implies I is equal, what is V by R? It is maximum current. Yes or no? E to the power minus T by Rc. This is the current in the capacitor. This one is the current in the capacitor. All of you got it? All of you have written? Yes or no? Tell me.
Yes, ma'am.
Written all of you?
Yes, ma'am.
Yes,
Yes, ma'am.
Yes, ma'am.
Very good. Now here I will completed writing.
Yes, ma'am. Yes, ma'am.
Yes, ma'am. Completely.
Yes, ma'am.
Very good. Very very good. Now here you see. You will tell me the equation. Copy में equation देखो मैं इधर उधर बोर्ड को और नहीं कर सकती हूँ. Okay. Now if I will draw the graph between current versus time, I will draw the graph between current versus time. I have found out three equations for voltage, for current, and for what?
Charge.
And for charge. Okay. So I will draw three graphs. I will draw three graphs. One is the voltage, three graph draw करो. One is voltage versus time. Another one is what? Charge versus time. Charge versus time. Now here you see. Look at the your equation. What is the equation of the voltage across the capacitor? Tell me. Voltage across the capacitor का equation बोलो मुझे. जल्दी जल्दी बोलो. देख करके.
V
V whole
minus
into
E power
1 minus e to the power minus p by
minus
Minus
Q RC.
और Q का Q is equal to capital Q whole into
Q
1 minus e to the
whole into
power
1 minus e का power divided by
RC.
r.
Current का
I max
IM
I
e
max
to the power
E power minus Q power
minus
C.
P by.
RC.
अच्छा. Now तुम्हारे पास t at 0 का condition है. You know the condition. What are the values at t at infinite? Now you substitute t equal to 0. Substitute t equal to 0 here. What is the value of VC you are getting? 0.
Zero.
You have got it 0 or not? Tell me. In the first case I have written.
Yes,
0.
ma'am.
Put t at infinite. Put t at infinite. How much you are getting? VC equal to? Put t at infinite.
V.
Capital V. So in between, that means it is exponentially rising from 0 to capital V at infinite. At infinite, VC is equal to V. In between, I am getting the equation as VC equal to capital V 1 minus e to the power minus T by RC. I will put here T equal to 1 second, I will get some value, T at 1 second, I will get some value of VC. T at 2 second, I will get some value. I will T at some period, I will get this value. At some period, here I putting the equation, I am getting different values. So the locus of the point, I am getting the curve like this. Am I clear to all of you now?
Yes, ma'am. Yes,
Okay. Similarly,
Yes,
charge versus time also, you substitute t equal to 0, you are getting the charge equal to 0, which you have already got. T at infinite, I am getting, what is the charge? Charge I am getting capital Q. So now that means it is exponentially rising at t at infinite, I am getting Q is equal to capital Q. And in between, it depends upon the equation, Q, capital Q whole into 1 minus e to the power minus T by RC. Clear to all of you?
Yes, ma'am.
Now what about the current? Tell me. Put
Same.
T equal to 0. What is the current now? Initially, what was the current? T equal to 0. What was the current? Tell me.
I max.
I max.
I maximum. Are you getting it or not? You put 0
ma'am,
on 0.
I
What is the
Yes,
current I'm
ma'am.
getting? 0. Yes or no? T
Yes,
at
ma'am.
infinite I'm getting.
Yes,
So it is exponentially decreasing and it is at
Decreasing.
infinite it is becoming 0. And what is the equation in between? This is equal to Im whole into e to the power minus T by RC. This is I am getting the equation. Understood all of you? All of
Yes,
you got it?
Yes, ma'am.
Yes, ma'am.
Still, I need more
Yes, ma'am.
response. Anybody having any doubt? Tell me. Okay, very
Yes,
good.
ma'am.
No,
Yes,
no doubt.
ma'am.
Very, very good. So now here I will, all of you have run the graph.
Yes, ma'am.
Here I will tell you one term that we call it as time constant. Time constant. What do you mean by time constant? What is my voltage across the capacitor? Tell me. Vc equal to capital V whole into 1 minus e to the power minus t by RC. And I equal to how much I am getting? EIM e to the power minus t by RC. Now suppose I am taking t equal to lambda. T equal to lambda I am taking, that is equal to RC. And I will substitute in this equation. What I will get? Vc equal to how much? Capital V whole into 1 minus e to the power of minus 1. Yes or no? I will get this or not? Okay. So here, if I'm putting this one, so if I'm putting this one, then 1 minus e to the power of minus 1, this will be equal to 0.632 into capital V. Okay. So Vc will be equal to 0. How much? 0.632 into capital V. So here I will define time constant as. So how will you define time constant? Tell me. Time constant is defined as the time taken, is the time defined as the time required for the capacitor. Tell me, define. For the capacitor voltage to charge to or to rise to how much?
Ma'am,
Ah,
ma'am, it's constant or constraint.
टाइम कांस्टेंट, कांस्टेंट नहीं, ये कांस्टेंट एक है, इट इज अ कांस्टेंट. ओके. Voltage to reach how much value? Reach to 0.6 through 2 of its final value. Of its final value. Understood? What is time constant?
Yes, ma'am.
So here I can show you the time constant as, if I am taking the time constant as lambda, here I am taking it as lambda here. Lambda is equal to how much I have taken? RC. Yes or no? So this will be equal to how much? This is equal to how much? Tell me. This point will be equal to how much? Okay. So this is your time constant. Am I clear to all of you?
Yes, ma'am.
Yes, ma'am.
Okay. Current, for the equation of the current, same. You put substitute T equal to RC.
वहाँ शायद
Substitute.
0.37 हो जाएगा.
How much is there? Ah, very good. Who is answering? Who answered? Tell me. Tell your name.
और अब
Saurabh. Very, very good. Good. So, I equal to how much? I maximum e to the power minus 1. Putting same thing. Putting T is equal to lambda, that is equal to RC. So, I to the power e to the power minus 1 is 0.37 into Im. So, how will you define time constant for the current? It is the time required for how much? Time required for the charging current. For the charging current. यहाँ पर चार्जिंग करंट डिक्रीज हो रहा है, इंक्रीज हो रहा है?
मैम डिक्रीज हो रहा है.
Decrease हो रहा है. So here I will write down, instead of rise which I have written for voltage, here I will write down what? Charging current to what I will write down? Fall. Fall to 0.37 of its maximum value. Maximum value Im. Am I clear to all of you? You write your own sentence. Time required for the charging current to fall to 0.37 of its maximum value. So now here I will show you what is your time constant. Time constant is your, let it be your T is equal to or lambda is equal to RC. T is equal to lambda is equal to RC. So here what will be your value? Tell me. What is this value? How much is the value? 0.37 into how much? Yeah.
9x.
Complete. Charging of capacitor is complete. Next we'll be having discharging of capacitor next class. Any doubt with this? Tell me.
No, ma'am.
No, ma'am. No, ma'am.
Okay. Only rate of rise of voltage across the capacitor का formula मुझे बोलो तो. Rate of rise of voltage across capacitor. Rate of rise of voltage across capacitor. How much it will be? Tell me. How much it will be?
0.632 volt.
What is my equation? Tell me. V equal to how much? Vc plus I into R. This equation I have told you. Yes or no? So Vc plus how much? RC dVc divided by dt. This one I have told you. Tell me yes or no?
Yes, ma'am.
So this implies I want the rate of rise of voltage across the capacitor. So dVc divided by dt will be equal to how much? V minus Vc. Vc will initially, what is the charge across the voltage across the capacitor? This is equal to 0.
0.
So how much it will be? It will be V divided by RC.
RC.
Okay. Rate of rise of voltage across the capacitor. This will be equal to how much? V divided by how much?
RC.
RC.
All of you got it? Complete?
Yes, ma'am.
Yes, ma'am.
Ritika, Rishabh, respond all of you.
Yes, ma'am.
Ritika,
Yes, ma'am.
Priyesh. Priyesh, you understood? Priyesh,
Yes, ma'am. Yes, ma'am.
Priyam,
Yes, ma'am.
you understood Priyam?
Yes, ma'am.
प्रत्युष, मुझे तुम लोगों का रेस्पॉन्स से ही पता
Yes,
चलता
ma'am.
है. प्रत्युष, you understood?
Yes, ma'am.
Kartika, Kaustav,
Yes, ma'am.
you understood? Ritik, Kaustav, you I responded. Kaustav Mitra, sorry, yes.
Yes, ma'am.
Okay. Kartika Patel. Kartika Patel 801. 801 absent. Harsh Kumar, 797.
Ma'am.
You understood?
Yes, ma'am.
Satya Prakash, Sharangi, 744.
Yes, ma'am.
771. Ankit Anurag. Ankit Anurag,
Yes, ma'am. Yes, ma'am.
you understood?
Yes, ma'am.
Arpit,